one thing we'll have a look at today by request is question 5 in the practice paper. Okay, so what you've been given is some readings for the watt meter and a var meter of a system connected to a 450 volt single phase 60 hertz line feeding an AC motor. Been given values of kilowatts and kVARs and asked to carry out some analysis. First thing being, sketch the power triangle and determine the apparent power supplied by this source to the motor and the power factor of the motor. So it's pretty simple-ish power triangle stuff in a way. So I'll do A on this page. So what does the power triangle look like? Well, we know it's a triangle. We know it's got a right angle. We just draw it out like that. How do I label the sides?
Can we just get a freehand?
Yeah, you don't need to do it with a ruler, yeah. S on there. P on the adjacent, because we're talking about that being the angle. And Q there. Yeah. So sketch the power triangle and determine the apparent power. So we've got to determine S, and we've got to determine cos of the angle if you're being asked to find the power factor. And so the method for that is, we know P, just tell me what the values are quickly. And Q, we'll use what I put. (16.2 kVAR). Yep. So the method for finding that is good old. So we've got to find S first. Yep. That's the root of 12.7 squared plus 16.2 squared equals. (20.5 kVA). Yeah. It's old hand me, but I always tended to underline final answers. The answer that the question's looking for, make it clear. Yeah? Because as a marker, I'll tend to be looking for that final answer initially. Is that right? And if it is, then what does the intermediate stuff look like? Have all the units been put in the right place? And am I happy with the level of notation being used? And then that's done. And if that final answer is wrong, then I'm looking for why that's gone wrong. Do you see what I mean? Yeah. So first place is to look for that. Yeah. Because then you've essentially got your marks. All right. Now you could go down the route that you went before, where you find the angle. Initially, my opinion is you wouldn't try and find the power factor first, because you haven't got S and P, you've got Q and P. But you could go round using the tangent to find the angle, and then getting the power factor first, and then using that to find S. But that seemed a lot of pointless hard work to me. Yeah, use what you've got. Okay? So power factor is, gentlemen, Yeah. P over S. You might put in there as equal to cos of the angle, which is also equal to P over S. Doesn't matter really. And then you just do 12.7 over 20.5. And you can do them without doing the thousands because they're both in kilo. Yeah. 0.62. Final answer, underline it. Moving on then to part B. Sketch a further labelled phasor diagram of the currents and use it to determine the in-phase and out-of-phase components of current, IP and IQ. So we're talking again about a triangle. We know that the cos of the angle at the moment is 0.62. Yeah. We know that's a right angle. What else do we know from that triangle? How would I label those three sides if I labelled them?
The line current.
This is IL, yeah. IP and IQ. And which ones from the question do we know at all? Any of them? No? Okay. How are we going to tackle that then? What else do we know from the question?
We know
So we know that P is 12 point, what was it? Kilowatts. Q anything else we know? E line. Where are we going then? Yeah, is that more or less what I got in my results? Yeah. You got my results printed out, Danny? Yeah. Is that how I've done it, is it? Yeah.
So then you can just use SOAP to tell us and find out Q, and then once you've got IQ, you can obviously just do IL equals square root of IP squared plus IP squared.
Yeah, you could do it that way. We'll put your alternative on there. We'll see if we get the same answer. IQ. Let's do it your way first, Luke. Come on. Method 1. IQ. How are you going to tell me how to do it? So you're going to find the angle. Yeah. If you go that way, what's wrong with using cos theta is equal to IP over IL, therefore IL is IP over cos theta. Why worry about finding the angle here? I know where your heading is going straight for that.
Yeah.
Yeah. But if you could find that line current first and then find IQ. That's just a little bit, you're going a long-winded way around everything. Yeah? Because that will give you the line current now. IP 28.2 amps over cos theta 0.62 equals 0.62. Yeah. And then, now knowing the line current, you can use Pythagoras to find IQ, square root of I line squared minus IP squared. .5 squared minus 28.2 squared equals. What answer do we get with that? Does that match doing it the other way? Because the question is asking you to find IP and IQ, it's not even asking you at this stage to find a line current. That's actually the next bit, and find the angle. So yeah, you're doing work that you're being asked for later, but the quicker way into this is simply that IQ is also can be got from the is Q over E, which is 16,200 over 450, was it, Danny? Yeah. And that comes out at more or less exactly the same, I would hope.
Yeah, you get 36 amps.
Which is near enough for me. Yeah? Alright? So you're straight in there with that then, as opposed to a bit of a long-winded way. Albeit that, yes, I know you're going to now calculate the line current anyway from that and the other, the IP up there. So part D is IL is equal to IP squared plus IQ squared IP was 28.2 and the answer to that is somewhere around about 45.5 amps. Okay. Oh, hang on. Part C is this up here, isn't it? Oh no, sorry. These are B and C. I beg your pardon. So that one's B, and this is C. I've got me letters out of sync, Thomas, all. Yeah.
So that's phase.
Yeah. So no, that's the current. And we can also get, always remember that we can get this angle from either the power triangle, the current triangle, the phase difference between voltage and current. That's always going to be the same for all those triangles. So in this case, power factor can come from IP, the current due to the power, over the current due to the apparent power, or the line current. 28.2 over 45.7 equals. We calculated the power factor earlier anyway, but let's check it. Do we get the same? Should do.
Yeah.
6.2. Therefore, theta is cos to the minus 1 of 0.62 equals, and whatever that is, 51.9 degrees. Okay? So up until there, no particularly difficult maths to get a grip with. Yeah? We're dealing with the old situation, the pre-power factor corrections situation up to that point. A little bit more tricky, and it's testing a little bit if you're more understanding in depth, because we're now talking about if we're going to add a capacitor or capacitors to the system to improve the power factor so that we get a cos theta of 0.97. Yeah? Calculate the reactive power needed to be provided by the extra capacitor. So it wants to know how many kVARs the capacitor needs to provide to the system to get this power factor from where it was, 0.62, up to 0.97. Okay? Part E, for reasons of how much I can ask, I won't be covering in this tutorial. Okay? Because that's why I've left it off there. That just goes into a little bit more depth on your understanding of the purpose of power factor correction, if you get this style of question. Alright? So, what we're saying here then is we originally got a triangle there with Q at, just remind me what that is, gents, please. That's Q old, 16.2 kVAR. Yeah. We've got a cos theta of 0.62. Yeah. P, which is not going to change, was 12.7, was it? Okay. And what we want to do is reduce to cos theta nu is 0.97. That's where we want to go to. That level there will be a new Q. Yeah. To do that, and I'm probably doing a little bit different to what a little bit more now than I've done in my worked answer sheet. Okay, because what we're going to do is provide some QC that's in that direction that effectively pulls this down. Can you see that that QC has to be Q old minus Q new, the difference between them two. That's the magnitude of it. The direction is opposite, but that's the size of it. So what on that board now can we calculate straight off with the information we've been given? Without looking at my answers.
You can find out the new Q.
Yeah. First find
I understand it, but that's not.
Q new. Yeah, but I'm doing it with a verbal description. To put what I've just said into a written description would be a bit too much to do for a set of worked answers. Yeah? But that's essentially what my worked answers are doing. We've got the information here from the power factor and the power to find out what the new Q is.
So
Yeah.
first we worked out the angle by doing cos to -1.
So yeah, you can do theta is equal to cos to the -1 of 0.97. Yeah? And you can work that out if you want and create an angle, okay? If you do that, you've probably got to round that angle and so on. So the proper way to do it would just be to leave the angle as cos to the -1 of 0.97. Because of the information you've got, P, and you want Q, that's adjacent and opposite, so we need to use the tangent, don't we? Yeah? Because what you're then going to do, you can use that directly. You don't need to calculate the angle. You can go tangent of theta is equal to Q nu over P. Yeah? Rearrange that because we want to find Q nu. So Q nu is P times the tan of theta. Then we just substitute cos to the -1 of 0.97 in there, and we're only going to round our answer once. Yeah? If that gets you in a muddle, don't worry about it. Calculate the angle and round it. It's not that significant. But this, in my opinion, this is the way to go about doing it. It's the more accurate way to do it. So we then go Q nu is equal to 12,700 times the tangent of cos to the -1 0.97, and do it all in one go. The answer to that is
I didn't put cos -1
you found the angle and then
and then did it. I can't 3.9 kg.
yeah. And what did you done it that way? Did you? Yeah. What's the answer in my answers, Danny? Just to see what difference it is. Because I think I've done it all in one go, ain't I?
3.83 bar.
3.18.
3.18.
3183 bar. And you got what?
3.
Yeah, so next to no difference.
Yeah.
Okay? And you get the full marks in the exam. I'm not saying you wouldn't. All right? 3183. doing it that way, and 3.19 doing the angle, yeah, which is equal to, as you rightly say, 3.18 kVAR. Okay, so we've got to get this power factor where we want it. We need a capacitor that will get the overall Q new to 3.18 kVAR. Yeah, but the question's asking how much reactive power needs to be provided by the extra capacitance. So we can now say QC is equal to Q old minus Q new, which is 16.2 minus 3.18 equals. What have we got down there, Danny?
What for the new S new? What are we going for? Okay, I'm working for it.
13.02. 13.02 kVAR. Yep. Because if you're looking at the diagram, what you've done is calculated the new overall Q. Which is that distance in there. The question is asking for how much Q has the capacitor got to provide, which is that value. And we already agreed that that value must be the old Q minus the new one. It's that distance in there. Because this value here is effectively pulling that line downwards and improving the power factor angle. Yeah, reducing the line current. Because if this line here comes down, it must be getting shorter because power's not changing. All agreed? Yeah? So that's where this Q in here is equal to the old Q minus the new one. This question could be turned round in you'd be given a capacitor value, how much does it reduce the power factor by? You'd then be calculating this value and taking it off the old one to find a new Q. So you could get this question a slightly different way round. Alright? Then the last part of the question is revised apparent power and new line current. So S new, how do we calculate S new? Got a magic pen on now. Square root. Yeah, that will be Q new. Yeah, and P doesn't change. Alright. P was squared. Q new was, and the value of that is yep. Did we calculate the original line current? Yeah, we did, didn't we? Yeah. Okay, how do we calculate IL nu?
X nu over E.
13,100 over, what was the E? Come out at alright. Don't believe that's a particularly difficult question, but it's about, the maths is not difficult if you understand the electrical bit. And that is about understanding this diagram. That's the old situation. You're going to add some of what's effectively negative Q this is the old situation. Going to add what's effectively some negative Q down here to pull this line downwards to this new position. Yeah. And understanding that principle is what is the key to this question. If you don't understand that principle, you could be blinking Einstein with maths and still not be able to do it because you don't understand the electrical principle behind it. Okay? So, need to know these triangles off pat and how to draw them and how to think about the problem in terms of those power triangles, current triangles, and so on. And then you've got this question and many other parts of the paper off pat as well. All right?